Good evening everyone. Today we will explain the graphs of motion in physics. Now, you know that once I say the word motion means that I'm studying four factors. I'm studying the position x, I'm studying time, and I'm studying acceleration and velocity or speed. So when we want to plot, we have a plot with time because everything is a rate of time. We have the rate of position or changing position is the velocity. The rate of a changing velocity is acceleration. So when we plot, always the x-axis should be the time because this is the thing that will express the formulas. First of all, this is the position time graph. So when we plot the position versus time, we will get a straight line. The relationship will be like a straight line when the velocity is constant. So it's not always a straight line unless the velocity is constant. When I plot this straight line, I will see that the velocity will equal to the slope, which is x final minus x initial divided by the time. So for example, if here was x final, I will minus it by x initial to get over the time to get to the velocity. Okay, here in this graph I have a positive slope. Positive slope means that the speed is constant and this speed is positive. So this body is going with a certain speed. And the acceleration here will be 0. Why the acceleration will be 0? Because as I mentioned before that the velocity is 0. That the velocity is constant. So when the velocity is constant, there is no change in the velocity, so there is no acceleration. So if I want to convert this plot, which is position versus time, into velocity versus time, so the velocity will be constant, I will have a straight horizontal line. By having this straight horizontal line, the acceleration, which is the slope of this line, is 0. So the velocity is constant and the acceleration is equal to 0. Next, when I have a position versus time graph and the position is the same, I'm not changing my position. Here it means that I'm not moving. So the velocity is 0 and so the acceleration is 0 as well. The last part is when I have a negative slope. Negative slope means the speed or the velocity is constant but it's negative, and the acceleration here is also 0. Why 0? Because the speed is constant. In the previous video I explained to you that we have a general equation of motion. It states that x final equal x initial plus velocity versus time. From where we bring this formula? We bring it from v equal x final minus x initial over time. So if we rearrange it, we will have x final equal x initial plus vt. This formula, we use it to find the final position when the speed is constant or the velocity is constant. Also, I'll give you another equation that states that the average velocity, how we calculate the average, it is the total divided by the number. So here the total will be 2 velocities, so divided by the number, which is 2. So v final plus v initial over 2, it will be the v average. Now, if we substitute v with the v average, so it's gonna be half v initial plus v final, and rearrange it, we will have this new equation, which is v final equal v initial plus at. So this equation is the equation that we use it to find the final velocity when the acceleration is constant. Okay, the acceleration should be constant. Then, if we take the first one, x final equal x initial plus half v initial plus v final times the time, and we use equation number 1. We substitute v final by equation number 1, so it's gonna be x final equal x initial plus half v initial plus v initial plus at multiplied by t, and then we rearrange this one. We will have that x final will equal x initial plus v initial time plus half at squared. When we use this equation, we use this equation when I have constant acceleration and I have the value of v initial and x initial. So here I use this one when I have the value of v initial only, but I use this one when I have the value of v initial and x initial, and they ask me to find x final. So this one for finding the position, and this one is for finding the final speed. Now then, here I told you that when I have x final minus x initial, it's equivalent to what? It's equivalent to v average times time. From where we bring this one, it's the same as the first one, but I just put x initial to the other part. Now x final minus x initial, I will substitute v average by this equation, v final plus v initial over 2 multiplied by time. So I will find that the time is equivalent to v final minus v initial over a. From where I bring this one, this formula, it's the formula of acceleration. Acceleration equal v initial, v final minus v initial over time. We just resubstitute them. Now x final minus x initial, we can make it as delta x because it's a difference. It's equivalent to v final plus v initial over 2, and the time I will substitute it by this one. So I will get the final equation. The final equation will be 2ax equal v final square minus v initial square. From where we bring these two, because when we do cross multiplication, or when we do a multiplication for these two brackets, one of them is negative, the other one is positive. When we do it in the math, I will get at the end the first one square minus the second one square, and a and 2 we put it to the other side. When to use this equation? We use this equation when I have the final speed and I have the delta in the position and I have the acceleration. I have the final speed here, or I want to calculate the final speed. Here there is no information about the final speed, only the initial. Here there is no information about the position, only speeds.